this. If I go to our channel, we're not up yet. Oh yeah, there we go. And I'll share this. I hope my microphone works. What else do we have? One is watching. We share this. Coding. Place. Oh my god, it's beautiful. Yesterday. So we have the flow channel, general. Look at this, it looks so bad, but yeah. Cool. Oh yeah, maybe I should tweet this also. Cool. I think that should be good. So we can get started. So today we're going to do the advent of Cadence as a warm-up. I think we'll just do one day because there's so much work I need to do with code in regards to code that I want to get done before Christmas Eve in around how far are we? Like 48 hours from now, like in Denmark. And then after the advent of Cadence, the warm-up, we'll do the smart contract for open offers, so anyone can like do offers on our marketplace, and then we'll do the front-end development so people can actually do stuff with the marketplace on the basic Beast website. So let's get started. So we are day 3 and it's the 22nd of December. So we are a little bit behind, but that doesn't mean anything. So I'm just going to read like what is it that we're supposed to do. I don't want the story unless I need it. Like, find the item type that appears in both compartments of each rucksack. What is the sum of priorities of those item types? What are they talking about? So, sum of priorities is something we have, and we have some item types. Find the item type that appears in both compartments of each rucksack. So we probably have multiple items somewhere. If you go and look at our input, we just receive all this. And they're all unique, I guess. What do they mean? Okay, so now we probably need to read the story. One elf has the important job of loading all of the rucksacks with supplies. Each rucksack has large compartments. All items of a given type are meant to go into exactly one of the two compartments. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. The elves have made a list of all items currently in each sack. But they need your help finding the errors. Every item type is identified by a single lowercase and uppercase letter that is A and A to refer to different types of items. Okay. Wait, what? The list of items of each rucksack is given as characters all in a single line. A given rucksack always has the same number of items in each of its two compartments, so the first half of the characters represent the items in the first compartment, and the second half of the characters represent items in the second compartment. For example, you have the following list of contents from 6 rucksacks. 1, 2, 3, 4, 6. The first rucksack contains the items. Okay. Which means its first compartment contains the items that's half, while the second compartment contains the items. The only item type that appears in both compartments is lowercase p. The second rucksack's compartments contain Jake, blah blah blah, and the only item type that appears in both compartments is L. The third... Oh, okay. Okay, so you just have to match it. So they always only share one. To help prioritize item rearrangement, every type can be converted to a priority. Lowercase type have priorities 1 through 26. Uppercase items A through... Wow, that's a tough warm-up. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16, 38. Okay, the sum of these wait, what? So P, really? That's the 16. So if A is 1, B, C, alphabet. I just have to confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16. Okay, 16, cool. Yeah, I get it. Got it. So if that's 16, 17, 18, 19, 20. Yeah, got it. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities? What are you smiling at, Raven? Find the item type that appears in both compartments of each rucksack. What is the sum of those priority? Okay, so that's how we calculate it. Okay, not too bad. So we always need to, we need to split it, and then we need to, yeah, cool. Flow playground. And we probably want this is like strings, and we want it as arrays, so strings, arrays, but I think. Yeah, we want it like that. And then for each string we'll check. And we'll find out which priority number it is, and then we'll sum them all up into one. So that's what we'll do. Do I have my previous? I can't remember if I played that. So previously we created something called Advent of Cadence code. I don't want to open up my history. I don't know what's in there. That's super creepy. Okay. I guess we'll use the script again. But we just want one big number. It's like an int. And that's fine, we got that. So I think I prefer having it lock, so nothing, and then just lock. Yeah, I prefer it like this. This is like easier to read. So we have like a sum variable, result is equal 0. Right, so that's good so far. Clear. What do we need? We need to have our data as an input. Just like here, let list equals, we can define it as a string, I guess, equals, and then we'll just have it there. So we need all this as strings. So we'll go to sheets, you can open a new sheet. Huh? Oh, that didn't work that well. Values only. Nice. So I don't have like some kind of converter like Max had, so I'll just do it my way, which is having this. Oops. Cool. Then I probably need a comma in the end here. So say whatever we have here. Yep, looks good to me. So I'll just continue this. There we go. New file, just a file. Let's go. Then we'll replace. Really? We cannot replace with this. Replace all. No, it didn't replace. Wait, what? Why can't I replace? Yeah. Okay, there we go. That's what we wanted. So now we got that. Now we insert that, and we have our list. So if we try and like log our list like this, yeah, it basically gives us the whole list. And if we confirm, yeah, it looks like this. Nice. So this should all be even, right? This is like, if you go to item number 0, we say length. So it's always even, because otherwise we would probably have a problem. Yeah, so they are all even. Cool. So now we have our curated data. What else do we do? We need to split them. So how do we split an array? That's the question. So what does it allow us? We can slice. So the way slice works is that it's, yeah, from integer up to something. So we slice, as we say from, which is like from, let's say 0 up to its length, which is length. So this would give us the whole thing, I think. Or would it? Oh, I probably need to do this so it's easier for me to see. Yeah, so this gives the whole thing up to this length. So that's inclusive. But we want the health of it. So we need like health. So we divide by 2. And then the health should be around here. And if that's correct, I'll just log list. How much was it? Was it 26? Length. Come on. So 26. So this part should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's, yeah, so now we know how to split. That's basically the splitter of each. So that's good to know. So we loop through the list, and then for each rucksack, sacks, for each sack, split in half. Oh, how many times do we need to run this loop? Because then you get an item, you check how many times does it appear, or you only check it once, that they have to, we need to match just one of them. So in this case, it should be able to find the word, I guess, T. So they only have one, right? So boxes, oh, yeah, it's always the same number of items in each. Alright, so we need to find the duplicates. So it's just by taking split in half, loop through each character in first half, and check. I wonder if the script can handle that much, but we'll see. Because this is quite a lot, looping through. Is there a faster way to do it? I don't think we have a faster way to do this. But I don't know if it can handle it. Because then check each who second of checking the common item, calculate the priority, I guess, yeah. Actually, you could message that to Flow. I think they are working on that actually, but I'm not sure. So calculate the priority of the common item. Yeah, I don't know if I'm not sure if we are actually allowed to do this double looping, but like in such a large, yeah, so much data, like 300 strings. That's a lot of computation. Which is kind of annoying because Cadence is limited that way. But let's see. If it works, it works. Let's see if it allows us. So how do I make a loop? Let's see how we make a loop. So for, okay, so that's how we do it. Loop through the list of sac, for each sac in list. So far so good. What do you want to do? You want to say for each sac in list, split the sac in half. So you say sac yeah, if I combine it with a front end, I could do that quite easily. Slice, so from 0, so let's see, that first half up to sac length divided by 2, and then let second half sac slice from the sac length divided by 2 to the sac length. So now we have looped through it. Let's see if that still works. That's fine. So now we have split it in half right here. What do we do now? Loop through each character in the first half. So now we need to, yeah, so this is where I think we'll probably mess up. We probably won't be allowed to do that, but we could try. I wonder how, I actually don't know, can we break? Oh, that actually works. Okay. If 1 plus 1 equals 2, well, let's just say true. If true, and then break. Does that work? Break. Let's just count. Wow. Equals 1. I want to see if this works. Lock I plus 1. Yeah, it worked. Because if we don't do this, what happens then? 300. Cool. Okay, so now we know that it has a break. So we're able to break if we find a match. So we basically just want to have a list of var list of common item list, which is empty. It's just going to be contain char characters. List of char. What? Why does it complain? Oh, okay, that's why. Characters, okay. We don't need this. So, common item list. So for each char in first half, oh, okay, you cannot do that. Really? Then we say variable I equals 0, then while I is less than first half length, then we say I equals I plus 1. That's how we look through it. And we say first half this I oh, hey sweet. Wait, I thought you would be out. Okay. Yeah, I'll make sure to airdrop it. But yeah, it's okay if you have to go. Oh yeah, I wanted to show this. I'll show this actually. Where is it? So I made this. So we just need one more float, and I can I've duplicated these, but I've made a Christmas tree. So we just need one more float. So we can do this. I don't know if you can see the screen, but yeah. So everyone who's been participating in the Discord has their image shown here. I guess I could also add some of the others because we know them. Oh, nice! Thank you, Raven. Yeah, I guess I'll add Max and Carl and the others because there weren't that many others who, yeah. Anyways. Okay, back to the code. Let's see, first half. So we wanted to loop through each each character. And that's what we do here. And then we want to check if this character is included. Does it have that function? That's the question. Because could we say second half include? No. Contains. It doesn't have that member. Well, what does it have? Address, any struct, capability, blah blah blah. Fix, get count. No, it doesn't show here. Yeah, Raven, how is your mom? Then while j equals 0, while j is less than second half the length, so while the first half is like, well, this character, then if char equals second half so this should always happen no matter what though. So we could just make this a boolean instead and call it false, but then we can loop through it. No. And comment found var comment found equals false. Comment not found. Then we say then comment found equals true. So what happens then? Like after this is over, this one. So when we have found this, then it just continues. Okay. Let's see, comment found, loop through the first half. If comment found. Let's just see if this executes. Okay, yeah, this doesn't let us do it. Yeah, so already now we're basically screwed because we have like so many loops. How do I do this then? That's the question. Is there an algorithm that could make it better? they could say nope, doesn't allow us to do that. Okay, it allows us to do 2 loops, but that's all we get. So can I do something docs that on flow? String. So these are strings. Do you have any functions for them? We can see the length. We can slice them to lower, encode. To string from characters. New string, to string. We have a character. We want to check if that character is anywhere here. How do we do that? Oh gosh. How did... Well, we loop through this. What can we do? We can get the first character for each year. What if we make a list of sec, for each sec, we just create first half items are characters. Let me just add it here. Let me just say append. Or do the same. Second half items. Half. Let's just do this. So we can lock first half. Yeah, works. Nice. So now we have all that in the list. Because then we can say if second half see okay, so the first half items contains second half then we have found a common item. Common item list append. And we break. Does that work? Oh, I should stop blocking this. Because now so does that work? Here it says it's T. Here it says it's R. Yeah. Here it should be D. Cool. Let's count this. Zero. Okay, we should have the break. Cool. So that works. Now we have all the comments. And now we need to calculate for each of them how much they're worth. Do I just need like the alphabet? Alphabet. Lit alphabet. Third party equals I could say oh god. B oh really, it doesn't work like that. Transpose proper no lower yes nice. So that's one, right? Two delete to 52, right? 52, yeah. Then we just say, how do we do this? This plus this. So we get this. How do we make a dictionary? We can say A. Like this, what? A. And then a comma. Yeah, something like this. That's not going to work. Also need something like this, because then we have them here, this here, replace, or it could actually be fine like this, keep it like this. Where is this? Oh, it doesn't like this. Okay. No, we can't keep it like this. So does it allow us to do this? Yep, it does. Nice. I think. It reads a little bit strange, but yeah, it's fine. So now we can calculate this, because we can say for each common, for each item in common item list, we say priority. Oops, probably need it underneath here. Priority, and we insert our item. This is, we got a string into a character. Character to int, right? So now we got a number, and we just need to add that number to our result. So result equals this plus result. So this is like an optional, so we just need to force it down there. And then based on that, we should get our number. Nice. So this should be correct. And we just cross our fingers that it's correct. Ooh, we did it. And there's a part 2. Damn, that took some. How long did this take us? Yeah, it took like 50. Oh, okay. Yeah. It didn't take an hour, but it took some time. Gosh. That's a great warm-up. So what do we have to do now? So that was the first half. We got gold star. Part 2 is, as you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badge. All of the badges need to be pulled out of the rucksack, so new authenticity stickers can be attached. Additionally, nobody wrote which item corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have different badges item type. So in the above example, the first 3 lines and the second group rucksacks are the next 3 lines. In the first group, the only item type that appears in all is lowercase r. This must be their badges. In the second group, the badges, okay, Z. Yeah. Okay. Priorities for these 3 items must still be found to organize the sticker attached. They are, is that correct? Let me see this. 18, yes, okay, that's correct. In the first priorities for these still found. 30. Find the item type that corresponds to each free elf group. What is the sum of priorities of those item types? Okay, so this is not much different from what we just did. So just call this like a first part. Then call this second part. Second part. There's only a minor difference, which every 3. So for each sack instead, we go through the sacks. I need to find something in common. So if we have this, it needs to check the 3 others. It could be nice if they were all split into we could create the list a little. So because could that make it easier? But that's more computation power that's needed. Do we actually want to do that? So if this checks all of these, so it's easier if these are just characters. Just this is still the same. We want to see the common item list. This is still the same. Keep and keep the above here. So we just need to change this inside here. And the way we can change it is that we say so it has to be every 3rd. Oh, but it's so much easier if they're grouped together. List for each sack in the list and say var new list, which is an array with an arrays of strings. But I actually prefer them when they have but these are arrays of characters, I think. Strings first. so much more easy to read then. But yeah. For each SAC in the SAC list, then I guess we can remove this. For each SAC in list, what do we say? I equals 0, so while I is less than 3, 0, so 1, 0, 1, 2, 3, then we want to for each SAC. Group. There's nothing here. String. We want to group them. Six. If count. If count is less than 3, then do this, else do this, where you reset the count to 0, and you append, you reset the group equals this, but before you do that is you say new list, append this group, append SAC, lock SAC, new list. That didn't work. It's because we need to say if count equals count plus 1. Yep, that worked. So now we have them in our group. GPC. That's not correct. Oh, that's great. Nice. So we get this. We get this. String. So now we don't need this part because we have already grouped them together now, just to make sure we don't have too many computations. So what do we need to do now? For each of them we need to check like for each group, so we loop through that for each group in list. We say we just check this. Why do you only have that many groups? Wait, what? That can't be right. Because when you have 300, yeah. What happened there? Oh, we lost some. What the heck? How did we lose some of these? Oh gosh, it is what it is. I guess we have to keep it like this then. But that's not good. If count is more than then append. Say group is 0. We need to do that 100 times. Check count. Check count. Check count plus 1. $300 times. We do that 300 times. That's great. What else do we do? New list. Thing. 75 only. What happens? Why does that happen? That shouldn't be happening. Do we skip some? I guess we're skipping somewhere. Yeah. So we skipped a sec. So the problem is that so we need to say group append sec and count is to 1. We still skipped one. No. Did it 992 times. How about now? Did we lose any? Doesn't feel right. We skipped something. So if we're at the fourth one, the count is now 3. So we skip it to this. And we say this group appended, clear the group, append the sack instead to empty group, and count is as 1. And then we go again. We see the 5th sack. We count 1 is just a 3. Okay, we skip here. What? No. No, that's correct. I don't know. Maybe this is correct. Not sure. We have commonest here. We say for each sack groups for each group in list. How many groups do we have? We should have 100 groups. So group try now in 0 count group plus 1 count. Please say 100 groups, 99 groups. We're missing a group, I think. Which group did we skip? We skipped some group. Yeah, that's what I thought. We skipped that group. So what happens to, let's say, the last group? I don't get it. Which one do we skip? do I do? So we wanted them to have. We wanted to have them in groups. We could also say every time we go third, then group them. Yeah, we could do it like that. So you could slice it like that. You could say these are all strings, right? Say so you just remove all this stuff. And say we keep the check count. So for every third just count here. Say count. Nice. Wow. I is less than 100. We say I equals I plus 1. So we do this 100 times. Say group is a string equals, we need this group is like the list slice from I up to I plus 3 that's inclusive, so 2 more. And then we say new list append group, we skip 0, 1, 2, 3. That works. So we lock new list and now it skipped this part. So now I try again. Why did it stop? Why is this then? List thing. Okay, now it looks more correct. thing. So we should have 100 groups. Nice. It works. This one works. This one is correct. Thank you, Raven. Oh gosh, this is so bad. So bad, man. What to do? I don't need this. I don't need to check count. So now I'll remove this. We can get back to this. We will get this. We'll remove this and add it here. Oops. Count a group. Yes, it's 100 groups. Nice. Okay, so loop through the groups, and then for each group we are going to do stuff. So we just have to go through the first half. So for each group, so now we have a group of string. What do we want to do? We want to say for each character. So the first two parts, what do we want? So group 0 and group 1. We want those to be arrays of characters. So we could say first stack, second stack equals, we want it to be characters here, like this. Wow. Nice. So you want these to be characters for each of the groups. Don't need this count anymore. We say how do we loop through this? Something like this. So we say it. Group 0 length first stack first stack is this group 0 and then var first stack list. So the first stack is this group, and we also see the length of this. You see the first stack list append first stack this. Then we get all the characters. And then we just do the same here. You see 1 second stack list. We see while second stack length, second stack list, second stack added there. And then we say offer time. Let's see if this runs. It runs. Okay, cool. So now we say while third sec is group number 2. Say while I equals 0. While I is less than third sec length. We say glass or water time. What does that mean, Raven? I don't know what that means. Glass of water time? I have never heard this before. Glass of water time. Oh, glass of water time. What? Really? Yeah. So what do we check? So if say if the first half, like if it contains this third sec character and it contains the second contains this one as well. What we want to do is that we'll say the common item append this third sec and then we break it. And we'll say I plus 1. Does this still run? Okay, this still runs. Nice. So this means that we should have this running block and we should be able to say result. Cool. So I think that's the new priority. I hope it works. Please work. Yes, it works. Nice. Cool, we did it. And this is totally readable code. So congrats to us for making this super understandable. So I guess I can share this, and I can also say share on Twitter. Cadence on flow. Solution on flow. Cadence. And then max darker than Ford. Wow, that took me some time. But we did it. Whew. It's Bluebird. Nice. So that only took us around 1 hour and 20 minutes. So to complete all the others, 21 minus 2, like 18 others. So if we say it takes 1.5 hours. So this is going to take us 27 hours to do. That's actually quite a lot of hours. Okay, I don't think I can do like 2 a day. Yeah, I can't catch up with this. So I'll just do it like, I'll just do 1 a day for each live coding session. yeah. Like working 27 hours, that's already a lot. Like we could get a lot of things done. There's a leaderboard, so I don't know how this leaderboard works. Is that the number of stars they have gotten? That's nuts. Because I have 6 stars, right? So if you 3 times 20, 21, how many you have? Like, yeah, a lot of anime. Whoa. Private leaderboard. Okay, so I can make. Oh, this is nice. So you can get others to join. Okay. So I can join my own. You can't join your own private leaderboard, I see. So. Okay, so here's myself. Oh, nice. This is so cool. Nice. I'll message this. Comment. Whoa, that's a loud sound. Where's the for? Yeah, we're going to create something called Cadence Challenges, I think. I'll look into that a little bit later, I think. When I get tired. But now it's time to start the day with some work. But I do need like a 10-minute break because that took up like a lot of energy, like mental brain power. Yeah. So maybe Cadence challenges. Nice. I am going to take 10-minute break. Be back later. Cool. Now that's done. I don't even know how to get started with this. Because it's been a while. Let's see. So we have the Beast Market. We have Beast Offers. So Beast Market should be good as this. You can't find the Beast Market. Wait, what? Oh, okay, I see. So I need to see royalties earned in that function. That's called purchase. So the problem is that currently we can't call a function that says royalties earned. So we need that. If you want to save royalties earned. Marketplace contract. What else do we save? We also save the highest sale. When do we do that? So when we purchase, if it's the highest sale. Receiver capability. Ooh, how should we do this? So when we create an offer, it has offer details. It has a vault reference. Oh, okay. So the offer details does have the amount, the offer amount. Okay. Besides that, we have Beast ID. Use the Beast ID to pay out royalties. So where are we taking this from? It's called from offers. So matrix market. Offer. So offers. Nice. So Dapper offers and Dapper offers. So when we accept, they emit this stuff. Create offer, remove offer, clean up, borrow offer. Or just deposit. So not much there. Okay. So in order to accept, we need the beast. We already have the royalties. We know what that is. We need to receive a capability. And it's just a void. Then we have precondition. We know the NFT, it's fine. These details. Say details set to purchase. Why is the highlighting so strange? And then we get the ID. And from here we send the beast into the receiver capability of this offer. We pay out royalties. Like this. We'll get the beneficiary. Or we can do that. So the problem here is that we need to make some changes in our Beast Market for this to work. Because the current way we do royalties is that we say, we call this and that's all in a cell collection. But we need some kind of function. You need a access account function that says save royalties, and it takes in the address that we need. Oops. So in order to save royalties, we need an address. What else do we need? We need the ID of the beast. The only annoying thing is that we don't have the data of that beast anymore. We only have the ID. But of course we could have a lookup if you want to find out which beast this is. Yeah, we can do that. Yeah, we'll keep it simple like that. If we have the information. So in order to save royalties, we need an address. We call it address. Oops, address. Call it address like this. And then besides that, we need an ID, which is right. When you want the ID and the amount. Okay. So the ID, which is a UNT 64, and amount, which is a UFIX 64. And then we get this stuff done. So we say if the address Snell board beast ID we call this price instead. We don't have the royalty cut. Where did we get the royalty cut? Got royalty amount. So we just add the amount here. Royalty amount. So what does this say? Oops. When we save royalties, we say, is this a little bit too... I'll keep it at this. We need the address, we need the ID, we say the royalty amount. We say, if it doesn't already exist, well, then we need to initialize it. And then we say if the amount is nil. Oh, okay, yeah. If there isn't already something, if this is the first time they have like earned royalties, we say let royalties from Beast. We get like the royalties from Beast. We say that this is equal the royalty amount, but otherwise we'll just add it. And that's the case if it's nil, because we can't add something that's nil. Yeah, that's why we do it. Cool. So this should work. So now we can like change the way this is written a little. So we'll say, we'll call our own function called BeastMarket. Save royalties. There's the address is equal to the address. What is it complaining about? Inspected. Okay. We say ID is equal bought beast ID. We say the royalty amount is equals price times royalty cut. And that should be it. Then we don't need this anymore, because we're calling that function. And this should be callable from anywhere else. So now we can say BeastMarket save royalties. Oh, am I writing a function correctly? Yeah. Save royalties. Address is address. I can just remove all this. ID is the beast ID. Royalty amount is equals, and let's try and get this. So we need the royalty cut. We just call it beneficiary cut. When you have the royalty, you can say royalty.cut, because it states right there. Besides that, we also need self details. We need the details of this, which is offer amount times royalty cut, because then we get it like this. So now we have saved it. So that's how we save royalties. Besides that, we also need to, we have another thing called sellers. So these are sellers. And then offers, when people make offers. Where is it stored? Where should you store all these offers? They need to be stored somewhere. We could store them centralized. But that's also complicated. I'll find out. It's cold. Be right back. I need like something that can keep me warm. Yeah, I really do. It's already a nice cube. That's so true. Oh, better. Nice. So, if you want to call high sale, it's basically just this function. Could admit that royalties has been paid. Could say something like cup event royalties paid. You say address, which is an address, and we say amount, royalty amount, which is a UFix 64. Royalty paid. And then recall this function. Emit royalty paid. Let's say address is the address. We say royalty amount is the royalty amount. Something like this. Just so we have that. Besides that, we have another account. Phone. This is check highest sell, which is ASCOR price, which is UFix 64, and there we just say this. BeastMarket, check highest sale price. Nice, done. And then we can also say check highest sale BeastMarket, check highest sale price, and the price here is the self details offer amount. There we go. So now we checked the highest sale, we paid out some royalties, we deposited the beast, and we want to receive, so we want a payment. This is going to be the payment self vaults. So the offer has a vault with capability, a provider. We borrow that and we withdraw the amount, the self details offer amount. There's a loss of resource, and then we get receiver capability, borrow, deposit from payment. Nice. So the person receives the beast, and the one who accepts receives the payment. And this offer, of course, can, okay, yeah, nice. So that's how we accept an offer. Then we want to have get details, which is just a return of return self details. Yeah. Destroy. So offer completed. You only have this much info. So we know if it's purchased, accepting address is nil. If it hasn't been purchased, accepting address will be nil. That's not the only time that we. So that's 2 times. Offer should also become emitted here. So when you're done, you want to say emit offer completed. So purchased receiver. We do have an offer address. We don't have this part. We don't have all this. Offer ID. NFT receiver capability. We call those Beast receiver capability. Offer ID. You also get royalties. Say metadata views, and we have something called royalties. Get royalties, which give you cut infos and give you this. We don't need this. The NFT ID. It's going to be Beast ID right here. Beast.id. Only once. Nice. Address, offer ID, NFT type. We don't care about this. Oh, let's use all that. We don't need that. We'll call this Beast ID instead. Beast ID, Beast ID. We use null in this case. Offer ID, offer ID. Beast receiver capability. So if we destroy the offer, we can only destroy it if it's complete like this. And nice. So that's that. And we can make offers, which looks like this. So it's the destroy function, pop in, accept init, just like this. So outside of the resource offer, we can make an offer. So anyone can call this make offer. Which basically creates the offer resource. I think we're going to have a offer function like this. How does Matrix Market do it? They have something called offer public. Do we have that as well? Oops. Offer public, offer public. Yeah, we have that. Cool, cool, cool. Okay. So this is Matrix Market. And the way they do it is that they have, just like us, right here. And if you want to make an offer, you need an offer manager in order to create it. You can also remove an offer, but where does this get saved? So you create an offer, open offer manager. Oh, that's an interface. Okay, that's why. Yeah, so open offers. So anyone. Oh, but who stores these offers? So in order to receive open offers, you need to have it. And then you can see what people have bid. Okay, so that's how they do it. That's dumb. That's a dumb way to do it. We need a smarter way. So what could a smart way to be? So the offers get stored by the users themselves. So they have an offer collection where you can see all their offers. And we read all the offers by going through an offers list. Because that's probably the easiest thing to do. Main path. Offers. That's a new word. Yeah, no problem. So we list something for sale. So once you become an offers, you're always going to be on the list. So we can check for your offers. And if you want to make an offer, we need to be able to save that offer. Be right back. Okay, back. So in order to do, we don't have more music. Play, lo-fi, no copyright. I guess I'll add it to later. Okay. So I didn't like this way. But we can do this pub resource. Yeah. Thank you, Raven. Pub resource offer collection. So everyone can have an offer collection where we have a offer collection public, I guess. Yeah. Pub resource interface offer collection public. For now it doesn't have anything. And from here we can save our bits. Offers. Is this correct? Yeah. So you have the uint. And then you have the offer. But that's the offer ID. And then we have an init. That says self offers like this. Then besides that, you can create an offer and you can remove an offer. You can borrow an offer. Makes sense. You can get offer IDs. So and anyone can clean up for you. So what do you want to do that anyone should be able to? So anyone can pop found get IDs. Which is UN64. Anyone can borrow an offer, or you just get the ID of the offer, and what you get is you'll get an offer, or maybe I should write Beast Offers offer. Call this offer public. Where you can get the details and you can accept the offer. Public, offer public. And there should be a post condition. Like this. Oh, an offer doesn't have an ID? I guess I need to make sure that the offer has an ID then. Oh, here it doesn't have. So when you create an offer, oh, just the UUID, I see. Okay, so that's how they did it. Yeah, I see. Makes sense. Why doesn't this work? Missing the structure, okay. Destroy. Offers. Does not conform. Do we have anything else? We want to be able to borrow. Yeah, that's the only thing publicly that we want you to be able to. So open offers, we can pop file, make offer. So besides making an offer, what else can you do? You can remove an offer. Remove offer. Just give the ID of the offer. UN64. Pop file, get IDs, which returns this UN64. Return self. Offers, keys, pop file. So we want these two functions, borrow offer, borrow entire offer. BeastOffers, BeastOffers, offer public. Not entirely the same. Offers as Flow contract browser. Borrow entire offer. Destroy. Cool. Now we have all the things we need, I think. We just need to make the functions. How much stuff do we have? Change this to this. Yeah. So when you want to make an offer, we do something like that. First, we copy this part, make an offer. So to make an offer, we need the wall breadth capability. Which is essentially this. So that's the first thing. Next thing is that we give the beast. Get the amount. There's a lead. Lead. Offer. Oh, new offer. New offer. Create. Offer. What? loss of resource. So in order to append this, insert let offer ID equals new offer UUID, and say self bits. So offers offer ID, we force it new offer of course they can't tell you what this is. Cadence course GitHub DAO. Let's get this. Oh, that's in another language. Okay, so that doesn't work well. Let old offer destroy old offer. Nice. That's how we make a new offer. In order to remove an offer, it's that simple. Let self offer self offers move key ID destroy offer, something like this. Problem is this is an optional, so in case we have to panic, cannot remove offer, the offer doesn't exist in this offer collection. Nice. There probably should have some events. Offer available. Offer has been destroyed. So when we remove an offer and destroy it, it will emit that offer is completed. If an offer has been accepted, it will always exist. So you make an offer like this, you remove an offer like this. And when you create an offer, this gets called in the init. Nice, so that's why they don't emit anything. They do have a cleanup function, because we need to clean up offers. Because what could happen? Well, what if there's could not find offer with given ID, but if we can find it, then say so if it has been but we can only do that if I don't know if that cleanup actually works, but that's not what I care about the most. What I care about is whether or not the offer can actually be accepted. But of course we could just hide the offer if there is not enough funds in it. And then we can either ask them to remove the offer or, yeah, that's how we do that. And when you have made an offer, we want to know about you. So sellers, something like this. BeastOffers, BeastOffers, Offers, Offers. To check self owner of this collection. We add offer to list, so we know what to read from. And this is a list. Besides that, we need a getter function to get our stuff. Pop func get sellers. So that's a list of addresses. Pop func get royalties, get all royalties earned, which is the whole thing. Address, dictionary, UN64, UFix64, return, so here return seller, BeastMarket, sellers, and here return BeastMarket, royalties earned, pop func get royalties earned, if any. So UN64 UFix64 this return BeastMarket royalties earned, which is the address. There we go. So just like this, we need pop func create offer collection. BeastOffers, offer collection, return, create self, offer collection. Upfront get offers. Address return BeastOffers offers. The real init function, init self collection storage path equals storage, just like cell collection. Offer collection, offer us, boom, like this. So now we have an init function. I think that was it. Why do we have a cleanup? Remove an offer. So we can remove an offer for you. But when would we do that? Self bids could not find assert Cadence purchase. So we can clean up your offers if they take up too much space. And if it's purchased, okay, cool. So we allow anyone to clean up. IDs, borrow offer and clean up. Yeah, we'll do the same. So offers, offer ID, offer ID. This offer, bam, bam, bam. Could not find offer with given ID. So we can help them clean up. So that's it. Nice. So now we have an offer contract, and it took us around 1 hour to do that. I think something like that. So now it's time to build the front end. Which is probably going to take 2 days. So if this is like 1 day, and then tomorrow, we should be good. How many hours do we have left? We have 9 hours left before Jacob's Dev Jam. Yeah, I just need like 10-minute break, and then then we'll deploy. I guess we'll deploy this on Testnet. We'll deploy these 2 contracts on Testnet, and then I'll review. So like 1 review contracts, skim, and then deploy on Testnet. 2 contracts on Testnet, and build out the front end, test out the front end. Yeah, something like this should be working. 10 minutes break. Nice, we're back.
Min computer är klar idag.
Mm.
Jag måste gå hem.
You know. Okay, I think I need a break. Let's get this. So do a quick review of the Beast offers. So we have the events, Beast offers initialized, we check it, yeah, it's being called, initialized in the init function. Offer available, what do we ask for? Well, if an offer is available, we ask an offer address, like who is creating the offer ID, offer amount, and which Beast ID this is for. And we check it like this, like we see that it's being called every time a new offer is being created. And besides that, we have offer completed, and that means that an offer has been resolved. Either it has been accepted by the owner or the offer has been removed or destroyed. So when do we call that? So we call it once here, which is when an offer has been accepted. We say, well, purchased, it's true, or it should be true at least. Yeah, that's set to purchased, yes, so that's correct. The accepting address is, of course, the one with the beast. And oh no, wait. Yeah, accepting address is the one who has the beast and will receive the payment. The offer address, the one who created the offer, we get the address here from the beast receiver capability. And we also double check that, yeah, when you create an offer, you give the beast receiver capability, which has to be a basic beast collection, and it's the beast collection public, so anyone can deposit beasts. So that's correct. We have the offer ID, which is just the ID of this offer that has been completed. The offer amount, which is the amount that has been offered, and the beast ID that we wanted. We also call it when we destroy a offer. So if this offer has not been purchased or like resolved, well then we just say that it's false, purchased false. Yeah, and then accepting address, well, we don't have any accepting address, we don't have any beast ID either, but we do have the amount, we have this, we have the offer address. Yeah, and if this isn't the case, if it has been purchased, well, then it still just destroys. So that's the events. Now another thing is the collection storage path. So it looks like this, and this is a way for us to help users to have a offer collection set up. And we have the fields, offerers, we use this. Right here, we check, well, when you create an offer, that makes you an offerer, and we want to keep you in our list so we know who to look for, like whose offer collections should be available. And we append you right here if you don't already exist, because we don't want duplicates. And we see here this is how we get all the offerers, just like this, and we initialize it, and that's it. We have offer details. What does offer details contain? Well, it contains the offer ID, which is just the ID of a certain resource offer. it contains the offer amount, it contains the Beast ID, like what are we offering for, or what do we want to bid on, and we have we look if it's purchased, and we have a set to purchase, like, and that's like a one-time thing. You can set it as true, and yeah, this is like our init, and that's the struct for offer details. Then we have offer public, which restricts what people can do with your offer. So they can either accept it by coming with the beast that you want. If they want to accept it, they also have to give us the FUSD vault that they have where they want to receive the payment. And then we also have get details, which is basically this. Oh, another thing we have to think about, like when we check get offers, we also have to check if the user has enough funds for it. Because if the user doesn't have enough funds, yeah, that's going to be tricky on the front end. Anyways, so get details. Yeah, you can fetch what does this offer contain. Besides that, an offer also has a vault ref capability, which is the vault where, like, when you create an offer, you basically say that we are allowed to withdraw some funds from you. And in the offer details, you basically say how much we are allowed to take from you. Besides that, we can see that we have a Beast receiver capability. That's where you want us to deposit your Beast when you create an offer. This could technically be someone else's capability, but yeah, that's fine. Besides that, what else do we have? And these are of course restricted, so it's all, so they can't be like, so they aren't like open for anyone. And this is like our init. Why does this look so strange? Fungible token provider. I don't know why it looks like this, but it should be fine. Vault ref capability. FUSD vault. We ask for the fungible token provider and fungible token balance. And then we ask for the Beast receiver capability. We ask for the amount that you want. And the Beast ID. Then we have a precondition. Well, if you want to create an offer, we check is the Beast receiver capability valid or not. We check if the amount, well, is it more than 0. You also check the vault ref capability. We borrow it. You say if the balance is it has to be more than the amount, because otherwise you don't have enough to buy the Beast. And then we say details. Well, we create an offer details, which is the UUID of this offer that is being created, this resource, and the offer amount which you have given, and the Beast ID that you have provided. And then we have offer details. And yeah, capabilities are right here. And then we emit offer available. Cool. So that's the init function for the offer resource. So what else do we have? We have an accept function. So anyone is able to accept your offer by providing the Beast NFT and the receiver capability of where they want to receive their FUSD. We have a precondition which says sell, like if this offer hasn't been purchased, like hasn't already been used, that's good. And then we can accept it. If this Beast ID is the same as the one that has been requested in this offer, that's also good. And then what we say the details, we set it to true, so it can only be accepted once, right? And then we get the Beast ID. Besides that, we check for highest sale. So if we insert the offer amount and say this function that's being called in Beast Market, what does it do? Well, it basically says the price that we receive. If this price is higher than the current highest sale, then the current highest sale should be this price, and we have a new highest sale. And besides that, we also pay out royalties. So we get our royalties. We use the metadata views royalties. We say Beast result view. We say type metadata views royalties as metadata views royalties. I think Jacob helped me with this. I'm pretty sure it's correct. We receive it like this, and then for these royalties we say get royalties for each royalty. Well, that's a metadata view royalty, and we say beneficiary cut. Which vault do they want to receive their stuff? So we say the vault ref capability, we withdraw our vault amount and say that this is the beneficiary cut of the from this vault. And then we say address, we get the address. And why do we get the address? That's because we want to get the receiver ref. We want to get the FUSD vault. So we say get account, we use the address from the royalty that we read, and we get the capability. This should exist. So you of course make sure that they can receive FUSD. It's quite important that we make sure that an FUSD vault is being set up in the transaction, so we should make a note of that. Basic Beast Marketplace. Make sure transaction when creating let's look at this. The first owner has to do that. Make sure transaction creates FUSD vault if it doesn't already exist. And the transactions that we want is so it should be when you unpack, we want you to create an FUSD vault. It should be when you put a listing, right? List for sale. Then we want you to create an FUSD vault. Yeah, I think those are the only times where we need to do that. So what else? Receiver ref, yeah, we get the FUSD vault. We cannot accept an offer if this doesn't work. We're going to panic. So if we can't honor the royalties, the beast cannot be bought, which is actually kind of annoying. But then we also know something went wrong though. But what can we do if they don't have a FUSD vault? I guess there's not much we can do. They should have an FUSD vault, but there are some cases where they might not have. Like let's say they have when you unpack, you become the first owner. When you evolve, let's say evolve, you also become the first owner of that evolved beast. So you should have a FUSD vault. When you hatch an egg, you also become the first owner. So you should receive this. But super annoying if they don't have a FUSD vault and then this beast is suddenly just stuck. I wonder if we should change that to like not panicking, but just say like let's say like if receiver ref is not nil, then we do this and we don't have to panic then. This is the only time we use receiver ref, right? Yeah, because then we don't need to panic. Oh, what? Oh yeah. So we of course remove it from the optional. Yeah. So we have something called loss of resource of the beneficiary cut. Oh. So the problem is that we'll use and that's only a provider. You only receive a provider and the provider can't. Oh, so there we would fail anyways. We can't give back the beneficiary cut. So I think the way we should change that is that we only ask for the beneficiary cut if it's actually needed. So in order to do this, we'll just have to say for each royalty, and then we ask for the beneficiary cut so it doesn't get lost. So that's how we fix that. Because then, yeah, we only ask for the beneficiary cut for this one if we need to deposit it. And then it looks like this. So we don't need to panic. We need to make the same change when we pay out royalties here. So where did we actually have this? Like payout royalties, that's something we got inspired by from Dapper. And that's because when they pay out royalties, like here, oh, okay, they don't panic actually. They just borrow. If they borrow, yeah, so if it's not nil, then they do the things. Okay, yeah, makes sense. Yeah, so they also have an if statement basically, but they have an optional binding, I think. So they say if that. Okay, yeah, we can write it like that actually. That looks better. So we can say something like if let receiver ref is equals get account, I guess. If that receiver ref is that, then we say so that looks better now. So we borrow. Yeah, when we specified it, it has to be that type of capability. And we say we borrow the FUSD vault. We withdraw beneficiary card. We deposit that into it. Cool. So that's how we're going to do it. So we have an optional binding. So if it's not nil, then yeah, we'll do that. Otherwise, we're just going to continue. The problem is that we can only save royalties if they actually happen. So we can also only do this if the above actually happens. So this is how we're going to do it now, like this. So now we have the optional binding. If the receiver ref is not nil, then say this receiver ref, I actually don't think we need this anymore. Yeah. We don't need to like, we can't force unwrap something that's, that's definitely not nil. So we get the capability, we borrow it. We get the beneficiary card. And then we save royalties earned like this. And we have to fix this as well then. So we say if let, we don't need just panic. Instead we say if let, then we can say receiver deposit. We need a beneficiary card. Like this. And then we save our data. Like this. So this is how we do royalties now. Payment withdrawal. Could also say payment. When do we pay? Where do we get the payment? So that's here, the payment. Vault, ref, capability. Borrow, withdraw. Oh, okay, this is wrong. Because this doesn't account for the fact that we will be paying double. So In order to do this, we need to get the payment first. Get payment. So first we get the payment, and then from the payment we are able to withdraw. So from payment we get the beneficiary. Yeah. So this is how it's being done. So we can remove that, the cuts, and then the rest is given afterwards. The same goes here. And the reason it worked here was because we used the buy tokens. And buy tokens, okay, we get the buy tokens. When do we get the buy tokens? We get them right here. Okay, that's why there's a difference in it. Yeah. So now that's correct. So we use a payment to withdraw some funds each time. And then we save the royalty like this. Yeah, that's right now. So that's how we pay out royalties. The way it worked was that we get all the royalties. For each royalty, we do like this. You get the address of the royalty, and with the address we can get the receiver ref, and it has to be an FUSD vault that's restricted to receiving. And we borrow that capability because it should be public. It's just by saying, yeah, get capability public FUSD receiver. That's quite common. And then we borrow the FUSD vault restricted to receiver, and we say we get the beneficiary cut, which is we use the payment that we had fetched, and then we withdraw a certain amount from it, which is the offer amount times the royalty cut, which is in this case 5%, and then we take this 5% cut and deposit it into the receiver ref of the one who is to receive this royalty, and then we save the royalty where we say the address, the beast ID, and the royalty amount, which is this amount. And then we keep doing that until all the royalties are paid. And then we increase underscore of the buyer, increase underscore of buyer, and we do it like this. We say beast collection, we create a new empty beast collection, then we deposit the beast into this collection, and then we say let a new beast collection, because we're going to receive from underscore increase underscore function. We say the wallet is this address, and we say yeah, the beast is this, and from that we are able to increase the hunter score. And then we need to withdraw this beast from the new beast collection. So the way we do that is we call it new beast collection, withdraw the beast ID as a basic beast NFT. We just call it beast to buy because we all have already used something called beast as a parameter. So we don't want confusion there. We destroy the collection and we transfer the beast to the offerer by saying beast receiver capability, borrow, deposit, token, beast to buy. So we just hope that this actually works. Like that the person still has a beast collection, but the person should have a beast collection. Because when they created the offer, we did check that. So it would be strange if they had destroyed the beast collection. And then we have to transfer payment to offeree, and that's the rest of the payment that's left after royalties has been paid. There's a beast receiver capability, borrow, deposit, like this. Oh no, receiver capability, borrow, deposit. How do we get the receiver capability though? The receiver capability is a parameter, that's why, okay. Yeah. When you accept, okay, yeah, that's your, so this is the user who calls the functions. They receive the funds. And then we say offer completed like this, yeah. Get details, quite simple. We just say return self details. And that's how we get the details. Destroy, we have already seen that, it's fine. Then we have offer, collection public. We have get IDs. We have borrow offer, where we just restrict it to offer public only. And yeah, we just have a post condition. We check if the result that we receive, like if it's equals null, or if the result UID is equals ID. Yeah, so either it has to be a nil or it has to be equals this ID when you borrow, and we want to make sure of that. So cannot borrow a beast reference. The ID return reference is incorrect. Cleanup function, so anyone can clean up in your offer collection if it has already been purchased. Then public resource collection, let's see. The way that works is kind of like a normal NFT collection. You have your offers. It's a resource dictionary of the offer IDs and the offer themselves. You initialize them. And then you can run this function called make offer. And if we look at where did we get this inspired by, it's right here. When you make an offer, you need to provide a vault ref capability, which is you who provide your FUSD vault and the balance, so we can withdraw from that. Yeah, it's only access contract, so people can like mess around with it. And then you also have beast receiver capability, which is where you want to receive the beast, which is mostly your collection, and then the amount, how much you offer for it, and which beast it is. And the way we do that is we say let new offer. We create the offer, we input the things you have given us, And then we say like, since you have created this offer, we add you to the list like this. And we get your address based on that you own your own offer collection. And then we say your offer ID is this new offer UUID. We insert it here. Could probably be inserted in another way. Let's see how an NFT collection would do it. The way NFT collections do it is that they say, yeah, it's the same way. So we have like the old token like this, and then you destroy the old token. Yeah. And in the init we have in the init of the offer we remembered that offer available has been emitted, so we don't have to emit it here. So that's how we make an offer. How do we remove an offer? Well, that's just like this. We say let offer self remove ID there, and we panic if we cannot remove the offer because it doesn't exist in this offer collection. But if it exists, well, then we destroy the offer. So that's how we remove an offer. Get IDs is just return self offers keys, which gives us an array of the offer IDs. How do we borrow an offer? I hope this is correct. We ask for the offer ID and we say BeastOffers offer, we restrict it to offer public only. And then we say let a ref and we get all blah 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 like this. This is how we want our offer. And we can borrow entire offer like this. To get a reference of it. And then we have cleanup, which anyone can call. Let's see, borrow. I don't think we need this though. I think we can go with just this. I think this should be fine like this. Yeah, this looks more alright. The only reason they need to do it here is because I don't know. I don't know why they need to do it like that. I should probably check. Matrix open offers. How do they borrow an offer? So the way they do it is they say they do it like this. They say self offers Yeah. What else do we have? We have the cleanup. So the way the cleanup works is that we have a precondition that says, like, we make sure that we can find the offer. If we can find the offer, then we say let this offer, and we remove it from our offers, and we assert that the details that it hasn't been purchased. Yeah, because if it has been purchased, cleanup means that it has to be purchased, I guess. Or what? Wait, what? Cleanup? Who can call this? Anyone can call it, so anyone can remove your offer. That's not good. That's because we do it differently, I guess. Or what? So assert get I guess they say assert that this. Okay, yeah, we check if the offer has been purchased, because if it has not been purchased, then we cannot remove. But if it has been purchased, well, then we can go to the store offer to help clean up. Yeah. And this is from Matrix Market. Let's see if that's also who has this cleanup function. Clean? No. Clean. So cleanup. Yeah, all offer is not purchasable. Yep, this is like a copy pasta. It is a copy pasta of Dapper, so that's good. Destroy. The way we destroy. Let event consumers know that this storefront exists. Okay, we can do that. Emit offer collection destroyed. Did I actually just save it like that? And then you have the offer collection ID, offer collection ID, self UUID. So we'll add that event, I guess. Pub event offer collection destroyed, and we ask offer collection ID, offer collection ID, which is a UN64. That's probably aligns with, yeah, collection destroyed, like this. I guess we'll also do it when we destroy a cell collection then? So where do you destroy a cell collection? Validate listing. Well, we can destroy. Why don't we have a destroy function? Your cell collection. There's no reason to destroy a cell collection if you don't have resources. Resources, you have to tell if it has to be destroyed or not. That's why we're not forced to do that. And that's why we don't have it there. Okay, cool. Okay. And then we have, so that's where we destroy an offer like that. Okay. How do we create an open offer? We create it like this. Create a offer collection. And how do we create it here? Create open offer. I guess we don't need the self, but basic beast, yeah, we say self for some reason. Not necessary, but yeah, I guess we'll keep it. Or it's to enforce that it's a, yeah, it's fine. Create offer collection. And now anyone can create offers if they don't already have a collection. They can remove offers, they can get IPs, they can borrow offer, clean up. Nice. And you can get all offer us. Yep, and there's no admin needed here. Do we need an admin for our other thing? We do check if we have an FES default. But that's all nice. So what can the BeastOffers do? It can increase the hunter score when an offer has been accepted. It will also check if this, when it accepts, it also check if this is the highest sale. It will also pay out royalties as it should. So it has all the important things, and it's also easy for us to see, and it only works with beasts. So we're sure that it's not vulnerable for those types. And then we have Beast Market. Which is pretty long. It should be fine, but you know, we need to review it. And the way we review is that we look at the Top Shot contract, Top Shot Smart contracts. So Top Shot Market. So we need to learn from them how that works. We create sale collection, owner collection, owner capability, FUSD receiver. Nice. Yeah. Small break. we are back. Let's look at this. It's been 6 hours and a half and 30 minutes. And we now need to review the BeastMarket contract. And as soon as that's done, we can deploy it on Testnet, I guess. And we just cross our fingers that it's fine. What the heck? This. Test out, build out front end and test out front end. So, do we actually use this? Yes, we do. We use this. We use this. We use this. We use this. Cool. So the BeastMarket contract, we have a bunch of events. BeastMarket initialized in the init. A beast has been listed. When you list a beast has been purchased. When you purchase a beast, I assume. Beast withdrawn. When you withdraw a beast. You high sell. That's that. That is when you are trying to, I guess, purchase as well. Yeah, purchase. Oh no, wait, what? No, this is okay. This is emitted when we have changed the highest sell. Beast withdrawn. When does that happen? That's when you cancel a sell. Remove it. Royalty paid is when you have saved the royalties here. Royalty skipped is when we could not. Save the royalty. And we have collection starch path, which looks like this. High sale. Check high sale here. Highest sale, highest sale. We initialize it here. Yeah, so we don't use it that much. Sellers. If contain sellers, then append get sellers like this. Yep, royalties earned. If royalties earned is nil, then we initialize it. Otherwise, if royalties earned address is also nil, then we have to initialize it like this. Yeah, and that should work. Royalties earned like this. Get royalties earned. Yep. So now we have a sell public. So if you look at our inspiration, yeah, well, what do we allow? We allow people to purchase from our sale collection. The token that gets withdrawn has to be the one that's requested. So we also check for that. to make sure that is correct. And we get the price, we get the IDs. We can borrow a beast. From here, we can validate a listing. So sell collection. Well, we have owner collection, which looks like this. And that's essentially a capability to our basic beast collection. A reference to it. And from there, we can get the prices like this. And we also have an owner capability, which is FUSD vault to receive. When we sell stuff, so when we initialize it, we need the owner collection and we need the owner capability, and we set it up like this. When we initialize, we should probably have a precondition to check if the capabilities actually exist. So in order to create this, you should have a precondition that says owner collection. We check the capability, and otherwise owners beast collection capability is invalid. We also do the same here, where we say owner capability check, then we say owners receiver capability is invalid. So they can't open up a cell collection if they don't have these things that are valid. I don't know why we didn't add that in the beginning, but well, it's added now. So we have our init. Looks kind of strange. Yeah, it should look like this. And we have the precondition. Nice. So after the precondition, we have the things we initialize. So that's the init function. Nice. Then we have list for sale, which looks like this. You ask for, you let it know which token ID it is, and you check the price. You have a precondition that says we borrow the collection capability. I would say borrow beast. So if that's not nil, well then it exists. Otherwise, the beast does not exist in the owner's collection. And then we have the price. We add it into the prices. We say token ID, price. To a price for the beast, we add the seller. If the seller is not in our lists, then add the seller to the list. And we emit that beast has been listed. Exactly like this. So that's fine. We are able to cancel a sell. The way we cancel a sell is that we say if this is nil, that it's actually for sale, then remove. Then remove this token ID and also set whatever is in there to nil, and then let them know that the beast has been withdrawn from a listing. It's listing. So let's see prices. Can you get all prices? Get price, get IDs. Yeah, so you can get the IDs and then you can get all the prices, I assume. So that's how you get that. And then we have, yeah, so that should be fine. It's exactly like Top Shots. I wonder if this should be a precondition though. The Top Shot market cancel, but you don't have cancel sell. List to sell, withdraw sell. Remove the return. Will revert if the token doesn't exist. You could also make it more explicit like this. Just have a precondition saying so it reverts. There's no reason to. Cannot cancel sale. Sale ID piece is it's not listed, because then we don't need this part. can do it like this instead. So we remove it and we make it look like this. Say we can sell. Yeah, so just like this, we check once more when we purchase. So when we purchase, we have the token ID, we have a buy tokens, which is a fungible token vault. It might as well be a FUSD vault, but I guess it doesn't matter much. A vault is a vault. Then we have the buyer. And what happens if you buy and you because the buy is right here. Yeah, I guess we just let you do that. Right, so buy tokens, balance, we want to make sure that it's enough. When you purchase, there's enough tokens to buy the NFT. So the balance has to be, whatever we receive, it has to be exactly what we want as the price that has been listed. And the price, we get it right here. We check if this price is the highest sell ever. If it is, it will update. We make sure that we remove it. Why do they do it like this then? Huh, strange. Anyways, we let the board beast. What are we doing here? We're getting the board beast because we want to pay out royalties, so that's why we need it. So this is how we do it. And how do they get the moment? So they say let board moment, self collection, borrow, withdraw, token ID as. Yeah, we do exactly the same. And then we pay out our royalties. We get the royalties, we solve like this, so things we did with Jacob. We say for each royalty in the royalties, that address of the royalty, we have an optional binding like if that receiver ref. If this is nil, where we get the FUSD capability, we say okay, get the beneficiary cut. So we like take the buy tokens, we withdraw a certain amount, which is the royalty cut of the price, and then we deposit that into the receiver ref. And then we save the royalty earned data to our contract. and then Beast Market contract, Beast Market contract. And if that doesn't happen, if we don't give out the royalties, we say that the royalty has been skipped. So this is when beneficiary does not have a public FUSD vault receiver, we'll have to skip it, because otherwise we can't purchase, and that's annoying just because of royalties. And that's their own fault in most cases. So owner capability. Hey Faldo. We're just like writing some smart contract for stuff for NFT Marketplace. If you have any questions, just feel free to unmute or write in the classroom 102. Then he went. And then let's see, we have owner capability. Deposit remaining tokens into the owner's vault. Yeah, so this is how we do that. Maybe we should. I actually like that sentence, because the good thing about that sentence is that it shows that the buy tokens, well, we have been withdrawing some of it when we paid out the royalties. So we can say deposit remaining tokens to offeree's vault. I like that sentence. Owner's vault. To the owner's vault. And then after that has been done, so this was us depositing the cut like this. And then we also want to increase the hub. Before we give out the beast or return the beast, we do want to increase the hunter score. So we say create an empty collection, deposit the bought beast. How do we call it? Bought beast. Oh, okay, there. Oh, nice. You could actually call this offered beast to buy, offered beast. So here is a bought beast, deposit it into that, increase the hunter score. After you increase it, we get it into a new beast collection. This new beast collection, withdraw the beast, destroy this new beast collection, emit beast purchased. We say token ID, price, seller, boom, 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 beast, nice. And that should be it. So now we have that was the purchase function. We don't want to change owner receiver capability, because why would we do that? Where do they want their vault? No, we don't want to then to do that. It just complicates stuff even more. They can only do it once, and they'll give us this. The issue is, of course, well, what happens if something happens to their vault? Maybe they should be able to do that actually. Let's say pre-new is not null. Yeah, have fun, Rian. Sounds good. I'm waiting for the picture. Change owner capability. So there could be a time where that would be relevant. So maybe it's actually fine to purchase. So say new owner capability, but it has to be a FUSD vault. That's the only thing. So we allow that. Should we also allow another thing? We could allow for the same thing here, like where you can update the capability. I don't think we'll need it, but at least we have it. So besides that, we have get price. So in order to get a price, we have a token ID. We say if let price, we do like this, return the price. If it's not nil, and then get IDs is just giving the keys. And then we have borrow beast, which is like this. If price is like this, then we have an optional basic beast NFT public owner collection borrow from the owner collection borrow beast. We do exactly the same thing here and we return the ref, else we return nil. How do we borrow an offer? So when we borrow an offer, we just say let reference. Yeah, okay, so this is different. Interesting. But that's because we're already calling a borrow beast. Okay, yeah. Yep, looks good. And then we have access account functions, save royalties, access account, check high sale. And this should be similar to when we do something with underscore, where we say when we increase a underscore, we check if whatever we have in there is nil, then we have to initialize it. And then we also have to do the same thing again. If whatever we have in there is also nil, we'll have to initialize it. Yeah. So if it's null, we add it like this. If it's not null, then we say whatever we had in there, we add it to the royalty amount together. And this is how we create a cell collection. Yeah. So the way you create a cell collection is that you say then you have this like this. So it's easier to read. So when you purchase like this. I prefer it like this. Nice. Get sellers, get all this. I think we are good to go. I can't see why this shouldn't be working. But I guess we'll find out. Contracts done. Yeah, I think that's actually correct. It shouldn't be aligned because like it's tilted. Yeah, it looks weird. The other side. Yeah. Oh, actually, it looks weird. Yeah. Yeah. So. Okay, I'm going to take. Yeah, I think this is good now. So I'm going to deploy this, and after I have deployed it, I'm going to build out the front end. There's around 5 hours until Jacob has his dev jam and I need to sleep. So I'll have and we have been working for more than 7 hours now, and we've been live streaming for 7 hours. How are you doing, Raven? Actually, like, shouldn't you be sleeping? When do you usually sleep? Like, my sleep schedule is like sleeping around like 4 p.m. and waking up like 8 hours afterwards. Oh, nice. 岂不是？But yeah, I'm going to take I'm going to take a break because I want to get some protein bars that I purchased, and then I'll like buy some groceries. Oh, that's a cute chef. Yeah, the party heart. So after I've gotten my protein bars and bought some food for Christmas, I'll deploy the contracts to testnet, and then I'll be back to build out the front end. Many hours. Cool. Long commercial break. Thanks, Raven. And yeah, sleep tight if you end up like going to bed, because I know you haven't been sleeping. I think. Oh, really? That's actually the same. Like, oh, that's the same as me. Okay, nice. But yeah, I just like need like a mental break after like going through this, and then I'll continue. Um, I do feel that it feels like even though I should have had enough sleep, that it doesn't feel, yeah, as if my mind is totally clear. But I don't know why that is. Maybe it'll probably change and get better. Anyways, AFK. No added sugar, yeah. Let's see. Right now I'm going to deploy on Testnet. Testnet, flow source. I think it's this one. Is it? Yeah, it's this one. Flow JSON. Flow project deploy. What the heck? Oh, okay, it worked. Nice. Let's get it. Nice, nice, nice. So now we have supports used for trading and Beast, blah blah blah. So we'll update this a bit. How does my GitHub look? Have I been doing stuff? Doesn't look that good. Looks terrible. Let's see. Anyways, so BeastOffers and BeastMarket, and we are ready to do some stuff. So now we need to so we just have to finish the front end on the testnet, and then we can let the community do the rest for the testing. So the basic Beast front end. For now, close all. Yarn. Package JSON. I wonder if we actually need this anymore. QTY. Yeah, we don't really need this anymore. All this GraphQL stuff. Remove package. Yarn remove. Yarn remove. Oh. Oh. Something like this. GQTY GraphQL. I don't think we need all this. And yarn install. Nice. Hey, generous kid. Actually, I'll type you in here, just so I remember to give out the float. How's it going, man? Oh, nice. So we actually, so generous kid, we're actually pretty close. Like I'm celebrating Christmas like at home, so in Denmark. So where in Germany will you be? If you're ever bored in Germany, you can just like drive up to Denmark. You're more than welcome. Let's see. Jan Dev. Really? Really? Okay, just a moment. I don't know what chat. I don't know if it has saved my previous like messages. Oh, it actually has. Oh my god. Yeah, it has. Yeah, I'm not gonna show my chat GPT. Just a moment. Yeah, because now it saves messages, your previous history. So I can't show that. Yeah, I'll use it. How to remove a dev package with yarn. So to remove, you can use yarn remove. Okay, so the flag is. Oh my god, like ChatGPT is so much better like than Google now. Like it's actually going to. I think it's going to replace Google eventually. It's that great. But of course, it's also a question like how are they going to monetize it? Because Google is doing quite well. Of course, it doesn't replace Google for everything. It doesn't replace like okay, which website you should visit, but it's pretty close to some extent to some of the things you would Google. Yarn remove. So there like this. Okay, now it's removed. Thank you. Thank you for the suggestion, Raven. It's so nice that you're always like one thing is joining and just like doing something else totally, but another thing is that it feels like you're always here. You're like my personal you're my personal chat GPT. Yeah, Google will simply embed it. Yeah, you're right. Like Google can easily embed that, and it basically just pops up like. So you're right about that. So in that sense, like it's not that difficult for Google. I actually also want to eventually. I do want to use ChatGPT to wrap it around some stuff we have for Basic Beast like avatars and stuff like that. But that's still like a work in progress thing. So we'll see. Yeah, I know. Oh, really? Only? Wow. Okay, maybe we should then just have like an early version. I just thought we should wait it for like the avatar where they can move their mouths. Yeah. So it's more like, natively? I don't know. Yeah, dev. Okay, so does this load as it should? So it keeps saying this browser list. What is browser list? Browser. No, I don't know what this is. Constantly ask me. I don't get this. Why? Or now I can remove it also. So strange. Oh gosh. Stupid browser list. Now I can't even remove the module. Now I have to do it all over. Discard all changes. Damn. Yarn, remove this thing. Remove this thing. Remove this. Remove this. Yarn, remove. Nice. Okay, so now we have this removed. So remove all these dependencies. Remove graph, kill stuff. Yarn dev. I guess I don't need these scripts anymore though. Some of them. Localhost. Nice, it's snowing. What else do we have? Okay, so this is the testnet side. Great. I guess we don't need this for now anymore. So we have to build out the stuff, the marketplace stuff. And we probably need to update this to something else. Just don't know what. Bulk bit, bulk. Why is it also so super slow? It feels so unnatural. That's really strange. That doesn't feel right. I wonder why that is. I guess I'll have to ask FR Labs what he thinks. But yeah, that's not what we were here for. So we want to be able to do a quick bid. And based on that, yeah, we should be able to bid on it. So you can bid a certain amount. Okay, so how are we going to do this? There's so many details. There's a button here. There will eventually be a purchase. There will also be a bulk bid here, where we want you to type in a number. Let's connect the wallet. It doesn't work, of course. What about now? please. Oh, okay, it works now. Nice. Thank you. And now a person can bid, almost. So we have a button here to bid, you have a button here to bid. And then if you go to the details eventually, you'll be able to see Beast details. Yeah. So from here you would be able to purchase and you can see the offers there. Okay, so there's a lot of scripts that needs to be figured out, and then a lot of, you can buy or you can place a bid. So we have 2 buttons there. And the question is also like, where do you list it? Like if you want to list a but that's fine. So now we have quick bid, buy, or bulk bid. That's on one page. This is marketplace page where you want this. What is this? OpenAI require API key or API key. Okay, I see. Set number of tokens the chatbot should generate. Prompt, what is your name? Oh wow. I see. Yeah. Yeah, it's not that difficult to wrap then. It can be done from the front end. Like, oh no, you can't. Okay, you cannot do that from the front end because there's an API key, I think. Oh wait, oh actually with the API, can you? Yeah, you can. You can do this from the front end. And yeah, yeah. The only reason that I will have a little bit troubles is actually because I don't know how to use process.env. I don't know how to use it with Versal. Yeah, I know but I'm not using it the same way. Like normally you would use, I'm using it like this, right? Like here. Yeah, but Versal, I don't know how to set it up correctly there. So I don't know. Right now I don't want to spend time on it. To be honest, there's so much stuff. Let's see the Beast details page. Beast details page. So we have a buy now, and we have a for certain amount, and then we have a place bid, and I guess you should only be able to bid from the front end if it's a higher, only a bit higher than current offer. And I guess when you accept, you can only accept the highest bid. So we also need to let you know to like, okay, from the Beast details page, if you're the owner, you can list like, so that's was from buyer perspective, or not owner perspective. So buy now or place bid, owner perspective. You can list for sale, delist. You can accept highest bid. So those are the. So either you can list for sale or you can delist it, or then you can accept the highest bid, if there is any bid. And you would be able to see your offers here. I wonder if share refresh. I don't even know how refresh buttons works. Oh, I know. It's just fetches scripts. What does that actually do? I don't even know what that does. What is that supposed to do? Oh, there we have more. Refresh, view, website, report. We're not going to have reports. They can Discord us. Come on. I don't even know what that's supposed to do. I guess I'll hide that option for now. Less is more. God, this looks not that good right now. Gotta fix it. But first, functionality. So we have quick bid, we have bulk bid. Eventually, we will have bulk buy. We'll have a quick buy. I guess we can wait for those options later, but I could also just make it now, so I don't have to make it later. Yeah, I'll make it now. Since we have Christmas anyways, and then we have sweep buy. That's all. And then we have the inbox, I guess. Inbox page. Show offers. Eventually it would be nice to have activities. How do they do that now? Do they still use GraphQL? Floaty.io. Floaty. Marketplace. Where's activities? Oh, there. What is this powered by? They don't say what it's. Or maybe they just have made something custom made for themselves. What about that find? Do they still use GraphQL? Like explore? Huh? You can't see activity. Latest listings. Yeah, how do they see the history? I guess it won't matter much, because what does it matter? Eventually it will matter, but I don't want to build it out yet. So show offers. Beast model view. Show offers. List for sale or delist. Accept highest bid. Accept highest bid. Nice. So we have this amount of transactions we need to make. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 transactions, and we know we're done. 12 transactions, and then a bunch of scripts that I don't even know how I'm going to make. So that's good. So in order to do a quick bid, you need to know that you need to see the beast, and we are able to see that. So that's good. We can do that. One step at a time. Where do we have this quick bid? Quick bid. So now it's called quick bid button, and it will open up the quick bid. Set quick bid open true. And it opens. So Beast Market, Beast List. Yeah, no. So we have something called Beast Market, and there we should have. There we have it. So the quick bid model, it has the selected beast. I guess we don't need this. Also don't need this here. Set selected beast to this beast. Okay, from there we're able to show the beast ID, but that's not enough. We want to know the name. Quick bid is stupid. Quick buy makes sense, because you just want to. We're not going to make a quick bid yet. That's because that's way too dumb. We're not going to use it anyways. Mind. So we won't do that. we'll have a quick buy. But you can only quick buy if it has a price. Otherwise you can bulk bid them. Quick buy. Yeah. Quite fast quick buy. Add funds with Stripe, so you can use a credit card. Interesting. Yeah, instead, it shouldn't do all these things. Oh wait, actually, let's keep this. 33. Okay. Interesting. Actually, I do want to know some information. Div. So beast. So name. Beast name. So beast name is Gecko. And Derby and Serial. Cool. So it shows the right one. Great. That's good. So far, so good. So a quick buy, so we can buy immediately. We have bulk bid. Oh, I really don't want to do that. Why does it show a total price? Let's see. New offer. Sneaky. That's a way to increase the volume. That is really sneaky. To do it that way, you input it like this, and then it calculates total price like that. Okay. I'll show royalty, first owner royalty. Yeah, let's show these things again. Bulk bid. Oh, that's not good. That is not what it's supposed to do. So you can always bulk bid, but you can't always bulk buy. It would be nice to do a collection offer though. So for each beast, you would do an offer. Instead of bulk bid. But that's a lot of resources. collection offer. You need a place to manage all your offers. Where should you be able to do that? So when we see the items here, we have a search. So from here you can see items. You have to buy tokens. So we still check. Yeah, we check if it's available. I guess I'll start with the simple ones first. So just quick buy is a simple one. That's here. Okay, cool. We only use it once. And it's not even really being used. Yes, it should. Use subprovider. So when we unpack, we have the use user packs. Let's see. What do we do when we unpack? When we unpack, we can input a pack ID? No. Oh, we don't use that at all. Okay, interesting. We don't use that. But we could require something like that. Nice. So now we need to create a hook. Use BeastMarket hook.ts. So I'm going to copy up some stuff. So we call this use BeastMarket. So we have a getter here that we don't need. We also don't need just one. We also don't need just one. So we don't need these two. Nice. So now we want to run purchase with okay. So the reason we prefer doing it there is because it's way easier than the hooks. Hooks are fine if it's for the getters, but transactions. It's easier not to use hooks. Let's see. Or is it? Claim all mails. Who's calling this function? Claim all mails. Oh really? Okay. No. Well, then I was wrong. It shouldn't be a problem. So this is what we need. So this is a purchase. Beast. Which asks for purchase beast. And then later we need something called const sweep. And in order to sweep, synchronous. Sweep. What is the difference between sweep and bulk buy? I think it's basically the same. Purchase movies. Beast IDs, got the number, erase like this, Beast ID, give it a number. 2 more hours.
Hello, hello.
Oh, hey, F. How's it going?
Doing good, mate. And you? How's it going?
Yeah, good. I've been doing a lot of design work lately, so I haven't been coding that much for a week. And then I also
Oh,
went to a Blackpink concert with Willie Blue because she really wanted to go.
yeah.
So I was also out of town. But yeah, yeah. What have you been up to, man?
So I was on the Flow channel and I saw that it was live doing the marketplace, right?
Yeah. I just
So yeah.
yeah, I just finished the offers contract and also finished like the marketplace. Like I'm pretty sure it's like I just deployed it on Testnet. So
Okay.
so I'm building out the the pieces in the front end to call the transactions and also need to write the transactions and scripts. So that
Oh, okay. And how are you doing like the marketplace on chain? Did you figure out it already? How is the contract?
the marketplace on train, like you mean like
Because you will not use a database in the backend,
oh
right?
yeah, right. Yeah, so marketplace on chain, I'm just going to basically run a script. So the way it works is that as you see here, right? I don't know if you prefer reading the
Yeah.
from here. Or I can also show it from. Yeah,
Okay,
we'll
but
just
I think I got it. You just will like put the address in the contract, right? The
yeah.
sellers.
So sellers
Okay.
exactly, and then I just like
Okay.
go
Yeah.
through all of them.
And like uh, when someone is buying it, you are take it out, taking the address out of this array.
Actually, no. So I actually
No.
don't. I actually don't do that, because then I have to
Oh,
like
okay.
then I'll have to check and see do they have other things that they are selling, right? Um,
Yeah.
so instead, I'll just say we just like go through the sale collection because we know they have created a sale once, and
Oh,
if the
okay.
data
Got it.
like because I don't expect let's say okay basic beast becomes bigger eventually if it becomes bigger what we'll do is on the front end we'll just run 2 scripts instead of 1, right? Or we'll make the front end run many scripts um, if it's a cadence problem with the script, um, but even if that isn't enough, well then we could always optimize it even more or create a whole new marketplace contract, because the thing is with the basic beast marketplace we just use capabilities. So we're not locking, we're not moving the resources or anything.
Yeah, yeah.
Yeah.
You are using the same approach from Starfront, right?
Um, I don't know if it's the storefront who made it or if it was Top Shot, but yeah,
Yeah,
like
yeah. But yeah, I mean like the same approach, like the same logic that the Starfront
okay,
has of using capabilities.
yeah. The storefront just have a bunch of things that we don't need. So
Yeah.
yeah, ours is more simplified, I would say. But there was actually one thing. I remember there was a problem. Today I'm probably I don't know. Yeah, I might be too tired for it, but I don't know why. But it stopped working. Some of it. I can't remember what part. Maybe it was the
Okay.
serial, but I don't. I'm not sure. Actually, right now it looks like it's working. It's so
Just
strange.
because I'm here, you know.
Yeah, I have no idea why. The style level is fine, but why didn't why did it stop working? Normal, okay, 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 okay. That works. That's strange. Yeah, honestly, I actually don't know why it works now. That's so strange.
Yeah.
What the heck?
Yeah, maybe on the live version it is with a problem. I don't know.
I don't know.
Or
Like, I think I actually wrote to you, but let's see. Did I write something?
no, I don't think so.
Strange. Let me just search for this. If all let's see. From user from BC. Right now I'm just like, why can't I search? Gosh, why can't I search for myself? How do I search?
But do you think that you texted me on private message or?
Yeah, I think I might have texted you here actually, but
Oh, okay,
but
okay.
I don't know
So,
why
yeah,
the
maybe I missed it.
yeah I don't know why, but I can't really search for my own messages right now. I'm not sure. Just a moment. Okay. Well, I'll message you another time. Like if it suddenly doesn't work, I don't know why it's
Yeah,
working right now. But there was
yeah,
something
yeah.
when I was combining stuff here, it just wouldn't work. But now it looks fine, and I have absolutely no idea why.
Yeah, it's just because I'm here.
Yeah, I guess.
When
Yeah.
I get off, this
Yeah, as soon
the
as you go
problem.
off, everything will stop working. But it was so
Yeah,
strange because I remember you left, right? And it just stopped working. And I was like, why? It was working fine before and now it's just doesn't. Or maybe it's actually on the live side. I could try that. But that's strange. It shouldn't change.
yeah.
So let's see on the live side, if I search for Saber, well, that seems to be working nicely. Dex number 28. Yeah, so that works. So what if I say it collapses all of them? What? So if I say what if I want both? Okay, that works. What if I want a shiny gold something? Oh wait, what? Now I need to pick Saber. Okay, so there's like some kind of bug though.
Okay.
But I think that's like another type of bug.
Yeah, I see it. Like should be able to see all the shiny golds, right?
Oh no, these are all the shiny golds right now that has been unpacked, so that's fine actually.
Oh, okay.
Yeah, it was just because before it didn't show them. I had to like press on Saber again.
Yes.
But there's some, I think it's some UI bug, but it's minor. Yeah, okay, I actually don't know. I don't know what's going on here, but yeah, it's fine. Anyways, back to the real code, the thing that I'm so tired. Like I've been like live, I've been working for more than 12 hours before I live coded, and the live code has gone on. I did have a break though. I did like buy groceries for 2 hours, I think.
Yeah.
But otherwise, it's like almost been 11 hours now. Yeah, like in the
Wow.
live coding.
Yeah. Yeah, I mean, that's insane,
But it's also because
yeah. Some years from now, like the people will see it.
I don't think so.
Slides and we understand why the Beast is so dope.
That would be funny, but I really doubt that. But yeah, it's online. But yeah, what are you up to? Like, what are your plans for the holidays?
So I will make a small travel tomorrow to a city. Like it's like a 1 hour car drive city from where I am right now. So yeah, I'll be there with the family of my wife and stay there for the weekend, you know.
Yeah.
But of course, I'll take my computer with me and keep coding there too.
Nice.
Yeah. we never stop, you know.
Yeah, I know what you mean.
Yeah,
Although I do
yeah.
wonder.
Raven knows this too.
Yeah, Raymond, he's always on. He's always ready.
Yeah,
That's
yeah. He's with like that black cat picture there that you like you don't see it. It's
yeah,
not like a colorful picture, but he's there just with his eyes.
yeah. But yeah, man. Whew. Oh yeah, I remember you were. I think yeah, you were the one who was interested a lot about like the marketplace, like how it should be built.
Yes, exactly, man.
Okay,
Exactly
okay,
that.
okay, okay.
I was super interested to see how we will do it because I will do something more complex. Like I will not storing an array. I will storing a dictionary
Yeah.
where we I will have like two fields. One it is like the key is the address and the values will be the IDs of the, let's say, storefronts, you know, something like that.
Okay, storefronts. I see. Yeah, that's why you need like a dictionary.
Address,
Uh,
yeah, address and an array of IDs. You see it. So when someone it is like putting some NFT to sell, we will create this key, this address, and create an array with the ID inside of it.
yeah.
So if he has more than one to sell, we'll keep increasing the array. And when someone bought it, we will decrease the array. And if the array is empty, we delete, you know, the the address from the dictionary.
Wait. These storefronts are those. Why are the multiple like the IDs? What are these IDs?
IDs are I'm calling it storefront IDs, you know.
Okay.
But yeah, because when we create a listing, you can say that this is a listing IDs.
Okay, so it's listing IDs. Okay, I see. Yeah, so
Yeah,
that's a little bit different.
yeah,
Okay.
yeah, exactly. So when the user is like creating a listing, we are generating a UUID and we are like adding this UUID to the array, you know.
Why do you need to do it like that? Like, why would you do it like that? Like, I'll keep it in the contract like that.
Because like I will be exactly what the user has to sell, and if he has nothing to sell, I will not search. I will not do a script to that address. You know.
Yeah, but why have the listing IDs? Like, do you want to save this? Like, what you just sent me, that field, do you want to save that in the contract? Or is it like what you want the script to come out with?
Yeah, I'm saving it because I need to save like all the IDs that someone is selling.
Okay.
You know, like the idea. Because if I don't save, I would save like, let's say, just the address. If someone's like has more than one NFT to sell, I will not know. And if someone, let's say that the user has five NFTs, he's selling five NFTs, right?
Yeah.
And he just sold one. I don't know, like that
Yeah.
he has four
Yeah.
more, and I will not be able to delete this address from the array inside of the
Oh,
contract.
okay, that's what you mean. I see. Okay,
Yeah,
that's a little bit
because
upkeep.
I want to decrease the maximum of like scripts running that I can, you know.
Okay.
If an address like doesn't have the listing, I will not look on it, you know.
I see. Okay, yeah, I would do it the other way around. Like, and you know that I'll just use the script always, just script.
Yeah, but my concern is that this could take a while, you
Yeah.
know. I don't know, man. I didn't test it yet, but I'm concerned about it.
Yeah.
In run scripts with different address in the blockchain, you know, and searching for listings there, and like keep adding this data to an array.
Yeah.
Like my concern. I don't know.
Yeah, I understand why you would optimize for that. So the thing is that I would the reason I also try and be careful with that type of thing, that upkeeping, right, that updating, is because I try to make sure that I copy as much as I can from NBA Top Shot, because I know the fact that they have been audited. You know
Yeah,
that
yeah,
anything I do outside of that, I have to be extremely careful, like, because you can really mess up like not obvious things, even though it's in Cadence.
yeah,
So that's why I'm being extra careful, and but of course updating like that thing is of course not like a, yeah, there shouldn't be any like really vulnerabilities there, I think. I hope
yeah.
not. um
Yeah, it's not super risky, right? We are just like updating the
yeah,
data.
it shouldn't be too risky, and you can
Yeah,
also just have like the if statements. The only risk is when, if you have like undefined like any structs and stuff like that everywhere. It's much better to just define like, okay, this is market, this is a storefront for this NFT. um but yeah, it depends on what you're making. um
yeah, yeah. I mean, definitely, I see your point, and I have the same mindset of like keeping. Like, I try to not do super tough stuff there, right? That be risky. Like I agree totally with you. And like right now, the basic beasts it is live, right? And the
yeah.
marketplace there. So the marketplace are the beasts that the users are selling, right? How many users are selling there? Do you have the data, right? How many addresses?
Or the marketplace is
Oh,
not live yet.
yeah. Oh, it's not live yet.
No. I'm working. I'm building this right now, right? So
Oh, yeah, yeah, yeah. Of course. Like
yeah,
there in the basic list, there we don't have a list of NFTs right yet.
yeah. But on the live side, we do have like a list, right? Like here, like these are all unpacked beast. So these are like on mainnet and live. And then
Yeah. Okay. So these ones, like you are acquiring them from user address, right?
yeah,
Different addresses.
yep,
Okay.
in one single script.
And how many addresses
That's a good
you have?
question. That's probably around. Right now, it's only 103. That's not that many. Eventually, it's going to
Okay.
be around. Like we have actually 700 holders, but it's just because a lot of people have been inactive, right? Like because it's been so many months. So don't visit on a like uh, daily or weekly or monthly basis. Um,
Yeah.
but yeah, we're probably going to run the script for around 700, I guess, 700 users, until it stopped working, and I need to like expand it to multiple
Yeah.
scripts. Um, yeah.
Oh, okay, okay. So right now you are using multiple scripts.
No, not yet, not yet. Um,
Oh, okay.
right now I'm only
I'll check
using
it
one.
out. I'll check it out how you are doing the code
Yeah,
because yeah, I mean, I'm impressed. It's 100, but it's super fast. I didn't know that would be so fast. Like acquiring 100 different addresses to get like the NFTs inside of it.
yeah. That's fast. Like just as you just saw, this is on mainnet. Like yeah,
Yeah, yeah, yeah. That's cool.
yeah. So it can definitely handle much more than this.
Yes, definitely. You don't need even a loader there yet. But later you can just add a loader, right? And it's
Yeah,
fine, like 3 seconds loading, super
yeah.
fine.
That's totally fine. Like if we look at the cons of having a database and like a backend that I would have to maintain, that's nuts. That's that.
Yes, exactly. Exactly. A lot of work there, so that don't make any sense right now, right?
Yeah. So let's see. If I were to make a script, why can't I write good? No, no. new folder, call it Beast Market, and I'll make this purchase Beast. I guess I'll just call it purchase CDC. And the way we do them are that we import. So how do we purchase? That is the question. GitHub, NBA Top Shot.
So you have a function to purchase inside of your marketplace contract, right?
Yep. And I'll actually link it right here so you can see it. In case you want to like browse around. And there, the reason we definitely had to use our own, right, like marketplace is because, well, what do we want to know? We always want to know, well, what is the highest sale of a beast? That's one thing. We also want to have dual wall royalties. So like highest, we want to have on-chain like highest sale. We can always say that's cool, but also just because it's easy to query. And then dual royalties, not that many actually support that. And then we want to increase hunter score, and that's the collector score. Like every time you trade, right? Like Basic Beast, the collection gets royalties, so we also want to reward that. And when you trade and you purchase from others, you're basically also making the ecosystem like much better, like more valuable. There's a volume that's coming, so we definitely want to like make sure that your hunter score gets increased by that, which is like this score, right? Yeah. Eventually, what you can do with your hunter score, I don't know actually. We'll find out.
Yeah, I see it. Yeah, that's cool.
Let's see. Yeah, so where was I? I was here. So in order to do this, I need to look at the market v2. If you want to purchase a moment, what you'll want is you'll want a fungible token that looks like this. So how do I import that the right way? So normally fungible tokens are imported like this. Does it still complain? Really? Still? Huh.
Yeah, sometimes I just close the tab and open again. I don't know if that was the issue, but
Oh, okay. Yeah, I'll try that.
to ignite it. Yeah, no.
I have no idea why that happens, but it's sometimes things work, sometimes they don't.
Yeah.
And sometimes I need to write it like this for whatever reason. Oh, okay. Yeah, okay, I see. It's because we need to do something like this.
Yeah.
And it still can't find the fungible because we don't have the fungible token here. Really? Oh, no. Here. This should work though. Why doesn't it work? So it's not this one. Okay. If I copy paste this, it still complains, and that's because Beast Market is placed on a lower level. Okay, so it's because of the level, like 1. Oh, there we go. God, genius. But, yeah, I'm so bad at this. I'm so bad at paths like this. It's so annoying.
There you go. You figure it out.
So besides fungible token, what do we need? So we need FUSD. FUSD. Beside FUSD, what do we need? Do we need non-fungible token? I don't think so. Because
No,
the
I think you
Beast,
need just BeastMarket, right?
yeah, and Basic Beast also.
Yeah, and maybe Basic Beast.
Yep.
So man, I have a meeting in some minutes,
No problem.
so I'll just drop now. But yeah, later if you keep on, I'll jump again.
Yeah. Awesome. Have a nice meeting, FLabs.
Alright.
Always nice to see you.
Thanks, mate. Thanks for everything. Bye bye. See you later.
See you. Transaction, Basic Beast, and then we need the Basic Beast market, of course. Beast market. Why doesn't this one work? Oh, it's because of the flow JSON. I need to add it. Beast market, Beast offers. Nice. Transaction. So now let's get the seller. We need to give the seller address. Seller address. What is this? It's just an address and the token ID and purchase amount. Just address. Token. We'll just call it Beast ID because it's only beasts. UN64. Purchase amount. Purchase amount is UFix64. So there we go. Couldn't import. It's probably some other JSON somewhere. Gosh. Why does it work here? So strange. Damn it. Oh gosh, I'm sleepy. make this code. We have number 6. Do you have anyone else joined? Oh, spam. Mini. Yeah, the float. Can't forget it. I hope I did it right. So, Willy Blue, BC, Raven, Jacob, Haha Yes, Landford, Sweet, FR Labs, Spam, Numini. Cool. Jacob, haha, yes. Yeah. Oh, it's been a while, man. It's all wow. Look at that. It's almost been like 9 days, or like 8 days, 8 to 9 days since the last time. Because I sometimes like count depending on the time zone for me. But still, that's God. That's way too much. 8 to 9 days. Yeah, happens, I guess. So just to make Willy Blue happy, she gets to be mentioned first. So Jake. Yeah. Landford 33. FR Labs. Bam. How do I spell it to Numini? Numini? Numini. I need to remember that like next year that I have to like increment. I'll expect you, Raven, to remind me every time. Increment poop, yeah. Poop is going to be nice, I think. I hope we have time to do some nice stuff with it. But there are so many things that I'm preparing to launch next year. Oh gosh, it's going to be nice, Raven. We're going to have fun. Live coding stream 6 awarded to participants after live coding stream number 6. Raven, Sweet, haha yes, Jake, Landford. I think this is it. God, my brain is starting to like, yeah. The speed and productivity level, I can like feel it. It's decrementing or decreasing. How to call it a day soon, I guess. God, writing the contracts took time. Actually, way too much time. But I guess that's just how it is. After increment. I don't understand the joke, Raven. I don't know if it's because I'm too tired. Oh, fuck me. Delete this event. Have to do it again. Damn it. Delete. Stupid Canva. Like who downloads something with like without a transparent background? That's so dumb. Like why would I ever, like, really? Yes, delete it. Why would I ever have a white background? Like who actually has that? There's a reason it's a premium feature. Canva. Okay, so I deleted that. Nice. Now I try again. Oh, it saved it all. Nice. That's actually not too bad. I can live with that. Let's try this again. One, two, three, four, five, 6, 7, 8, 9, 10. Nice. Yeah, now it looks better. This looks good. Soulbound, not claimable. Let's try and create it now. Come on, save. Yes, it's saved. Now it looks better. Yep, works. Live coding stream number 6. Like I can't, by the way, Raven, I can't rewind my memory 20 seconds back. It's harder than one might think. 1, 2, 0, 1, 2, 3, 4, 5, 6. Okay, yeah, sweet. She got her cereal. Oh, I'm not gonna rewatch that. Oh, but did I reward it? Did it work? Nice. Nice, it worked. Okay, cool. Nice. Now we have the float. Now we need the Christmas tree. Christmas tree, yo. Just need this. I just need to add it right here. Need to add number 5 right here, number 4 right here, number 3 right here, number 2 right here. Oh, look at how cool this looks. How about that? So we now have, I think, Bam, he's a new person in this image. No, I haven't looked at it. I didn't rewatch because if I rewatch Raven, the thing that's going to happen is that what's going to happen if I rewatch? Oh, oh lol. Uh, that's why I'm here. I actually didn't even realize Pam was still here because I didn't have Discord open or that part of Discord. Oh wait, why am I making Numini transparent? He's basically a logo. Can I just copy? Or copy image is better. Yeah, let's go. It's in. You know what, I'll let Landford be here. Yeah, it's a big crowd. I don't even know where to put people. Oh gosh. Numini. Actually, maybe it's fine that he doesn't have a background there, because it's quite cramped. Okay, was that everyone? I think so. That's funny. You know what? I don't mind. That's way too funny. How do I do this? I'll have to add a page, and then I have to add. Can I? No, I can't. Damn. I need to find a template. Where's the design? What's my designs projects? See all. So it has to be this one. Oh, there she is. Ish. On same place. What? Okay. Yeah. Yeah, I just made her really subtle. Cause you know, she's actually quite creepy. I'll actually. How much? Okay, now you can't even see her. Like 2, that's what she gets. Yeah, she can get this. What? No, wait, they don't let you. They do? No, they don't let you. Anyways, that's enough. Oh my gosh, she's way too big actually. She's way too creepy for me. And she can be right next to Bam, because she scares me. I don't want her next to me. It will disappear after compression. You think so? Oh, I removed the background. Okay, that was dumb. Okay, yeah, this time it's nice to keep the background. I still see her. She's still here. Right next to Bam. Oh, maybe you meant compression on Twitter. I don't know. Anyways. Oh, okay. I see. Well, really? Oh, okay. Yeah, well, you know, it's going to be on Twitter, so I guess from there you would be able to find her. Like, she's supposed to be an Easter egg, right? So it shouldn't be too obvious. And she's also, like, super creepy when you're... Yeah, okay. Was that... What the heck? Wait, that's really bad. Like your compression. Yeah, okay, you can't see anyone, so it doesn't matter. Anyways, the Christmas tree. Yeah, I think it looks stunning. Nice. So that's probably the most productive thing I have done today.